Alright guys, today's goal. The learner will understand the logarithmic functions and their graph. So we're going to be looking at inverse of exponential functions, common logarithms with base 10, natural logarithms with base e, graphs of logarithmic functions, and measuring sounds using decibels. That's an example of when to use logs. Now, let's take a look at some definitions and some properties before we get into this, okay? Alright, changing between logarithmic and exponential form. If x is greater than 0 and 0 is less than b and b does not equal 1, then y is equal to the log base b of x if and only if b to the y equals x. Another way to remember this. Base to the exponent equals a number if and only if log of the base of the number equals the exponent. Ben is the same thing as the log of any. That's to convert from exponential to logarithmic or logarithmic to exponential. Okay? Now, logarithms are inverses of exponential functions. Here's the exponential function. Here's line y equals x. Reflected over that, you get the log b of x. Okay? Basic properties of logarithms. For 0 less than b and not equal to 1, x is greater than 0, and any real number y. Log base b of 1 equals 0. So log base 2 of 1, 0. Log base 3 of 1, 0. Because if you convert it to exponential, you get the base to 0 equals 1. Log base b of b equals 1. So if the base matches the number, it's 1, because you get b to the first equals b. Log base b of b to the y equals y, because b to the y equals b to the y. So if I had log base 10 of 10 squared, it's 2. And b to the log base b of x equals x, because they're inverses, so they undo, because the log base b of x equals log base b of x. Okay? So these are properties we need to know. Let's keep going. An exponential function and its inverse. So here's f of x equals 2 to the x. So how do you find an inverse? Switch the x and the y. Solve for y, which means you got to take the log of both sides. Or you just think about Ben is the same thing as log of Benny. So log of the base of the number equals the exponent. Okay? So that's how they got that. If you look, you have 0, 1, 1, 0, 1, 2, 2, 1. So they just flip. So they are inverses of each other. Common logarithm. So if you see this word, it means it has base 10. It's also written like this. Log of 8, that means log, that means the base is 10. Okay? Logarithms base 10 are called common logarithms. The common logarithm, log base 10 of x equals log of x. The common logarithm is the inverse of exponential function y equals 10 to the x. Okay, so we're still defining things. Basic properties of common logs. Let x and y be real numbers with x greater than 0. Log of 1 equals 0 because 10 to the 0 equals 1. Log of 10 equals 1 because 10 to the first equals 10. Log of 10 to the y equals y because 10 to the y equals 10 to the y. 10 to the log x equals x because log of x is equal to log of x. Okay? So again, these are basic properties, very similar to all log properties. Alright, let's move on. Solve the equation by changing it to exponential form. So we have log base 10 of x equals 4. So remember, base to the exponent equals the number is the same thing as log of the base of the number that equals the exponent. So we're in this form and we need to move to this form. So b is 10, the e is 4, the n is x. 10 to the 4th, there's 10 squared to the 3rd to the 4th. Okay? Hopefully you remember doing this from last year. All right, we're going to have to make a little error here. It says basic properties of common logs, but this is say basic properties of natural logarithms. It says let x and y be real numbers with x greater than 0. Natural log of 1 is 0 because e to the 0 is 1. So natural log, remember, natural log is equal to log base e. Okay? Natural log of e is 1 because e to the first equals e. Natural log of e to the y equals y because e to the y equals y. E to the natural log of x equals x because natural log of x equals natural log of x. So let's look at some examples with some natural logs now. So here's graphs of common natural logs. Okay? Here's the common logarithm, log of x. Here's the natural log graph. But notice they both have 1, 0. Okay? So let's look at this. It says, describe how to transform the graph of y equals natural log of x into the graph of natural log of 2 minus x. Okay, so first thing I would do is rewrite it this way. And then what you need to do is actually factor out that negative. So it kind of looks like this. So now, you would say it is, well, got to get the order right, Mr. McGaw. So first it was shifted 2 units to the right because the minus 2, and then reflected over the y-axis. Because look, if we go back to the common natural log here, see how it goes from x equals 0 to positive infinity, but if we look at the graph currently, and it goes through the point 1 comma 0, this one still goes through the point 1 comma 0, but it was reflected. And see how, now look, this is why it was shifted right too. Okay? But it was reflected because now it goes from 2 to negative infinity, or negative infinity and ends at 2. Alright, let's look at some more examples. Okay, this is a definition that you're going to need to know for word problems. Decibels. It says the level of sound intensity in decibels, dB, is beta equals 10 times the log of I divided by I naught, where beta is the number of decibels, I is the sound intensity in watts per meter squared, and I sub 0 is 10 to the negative 12th. This is a constant you will need to remember. Watts per meter squared. In the threshold of human hearing, the quietest audible sound intensity. Okay? So those you're going to need for some word problems. So make sure you write that down, or make sure you remember to look for it. See you guys tomorrow.